Good night. Today we are going to explain the first exam. The members of the group are Juan Sebastián González, Miguel Ojeda, and I, Kimberly Ballesteros. We have the next situation. You work in a company dedicated to packaging school snacks in individual boxes in a warehouse with the following dimension: length 30 meters, width 20 meters, and height 3.5 meters. The operation generates quite a few food odors, so you decide to design a general ventilation system. The conditions of the operation are the following: number of workers 188, most tasks are performed standing at the same workstation, and to minimize noise, the use of 10 extractors is established. Define flow rate per extractor following the number of people method, and flow rate per extractor following the method of number of renewals. To define the flow rate, we must first find warehouse volume with the following equation. Volume is equal length times width times height. We replace data. Volume is 30 meters times 20 meters times 3.5 meters. So warehouse volume is 2,100 cubic meters. To determine flow rate of extractors according to the number of people method, we must apply the following equation. Per capita volume equation, where we divide the total volume of the warehouse by the number of workers. So we replace data. Per capita volume is equal to 2,100 cubic meter divided by 188 person. Then per capita volume is 11.17 cubic meter per person. Once we find the volume per capita, we apply the equation of flow rate per worker. We check in the table of minimum ventilation required. We must find enclosure volume and flow rate.
Well, as the volume calculate is not in the table, we must interpolate the data to determine the flow rate per person. The interpolation is carried out through Office system in Excel through a scatter plot. When graphing the data in the table, we look for the equation for the straight line that is closest to the trend of the data. This equation of the logarithmic type. Once we have found the equation of the straight line, we calculate the flow rate required for the calculate per capita volume. Uh, this is the equation of the straight line. Then we substitute this value into the equation. Then this is the result: 25.46 cubic meter per hour per person. Next, please. Then the flow is multiplied by the number of the people. This result is divided by the number of the structures, and this is our theoretic flow. This result is 478.65 cubic meters per hour per structure. And finally, the last result is multiplied by the safety factor of 10% to have our real factor, our real flow per structure. And this result is 526.51 cubic meter per hour per structure.
For developing and second point, is necessary the following consideration were taken into account of the calculation: the flow rate in the ventilation system by means of the method and renewables. First, the warehouse is located in Bogota City. The regulation and implemented are the Peruvian standard EM30, while the environmental and geographic conditions are very similar and Colombian conditions. Additional, take into account that the per capita area is 3.19 square meter. The egg and warehouse is a 3.5 meter. The sites begin be an activity is which other are generated but not particular meter. And activity is developing in a cold climate zone. We consider it as the reference. The type of location is big warehouse with the number and renewables six renewables per hour. With this date, the total theoretical flow rate is they calculate for the volume of the warehouse. That result is 12,600 cubic meter per hour. They take into account that the 10 extractor will be installed in the warehouse, and that flow rate per extractor is calculated with the total theoretical flow rate divided by the 10 extractor, and result is 1,260 cubic meter hour for extractor. They calculate the real flow rate for extractor is multiplied by the factor and safety of the 10%, and the result is 1,386 cubic meter for our extractor. Thanks.
Thank you.